All right, so sorry about that. We had some technical difficulties beyond our control, technological stuff. We have to get it back going. So we're back on the brake light switch. All right. Yeah, we're back on. So we have a hot all the time for the brake light switch. All right. So this is a. All right, I'm mute. So the brake light switch, as in this case, it goes to the from the brake light from this relay to the brake lights. Also, it sends information to the ECU for different functions. For also the I stop and for torque converter release and lockup application, and also for your rate of deceleration to establish control of the fuel injector. Right? Yeah, so yeah, and it also helps with the and this circuit and this system, it also helps with the anti-skid control unit also. Yeah, and the transition for shifting lockup control. So you see shifting lockup control down here. So information to the ECU for shifting lockup and of course release, and also for the anti-skid. And like we said, it's also used for I-stop application. Start and stop. I think it's the I-stop. Okay, so this is your on circuit. Yeah, it's pretty much straightforward circuit. Just the same. You have your source, your main element, your control, and your output to the on. So for application with the um supplementary restraint system, your SRS are more commonly known as the airbags. Then you will have the on coming through the spiral, the on circuit coming through the spiral. So this is where you would do that check to see if the problem is downstairs or is upstairs. So right here is your on button, on switch coming through the spiral cable and going to the relay. So if you block this out, once you apply this, once you press it on, then you should get on this leg of the thing. So like I was telling you, with the different type of relays, and this number you have 1 and 2, and you have 3 and 5 as to the other relay. So this would be your input to the relay from the spiral. So if you press the on and there's nothing at this point at the relay connector, then you don't have to ask no question. The problem is upstairs. Right? So if everything is okay and you're not getting out, and you have your source there, then the big possibility is your relay. And of course, there are ways to physically check the relay to confirm that the relay is not working, either separate and apart from switching with a good known relay. So here we are doing a voltage drop test. And remember now, like previously with the from the alternator system, the starting system is pretty much the same. So the voltage drop is across is the same. Is to um, investigate any possibility of high resistance within a circuit or a group of circuits or number of circuits. Right? So for here's a chart, and this is not gospel. There's a chart for wires, and for wires it's 100 millivolts. That should be 100 millivolts. And for wire connection is 100. I don't think these are right because them have volts. Bring this up for me. I want to see clear with that volts, with them volts. Yeah, yeah, and follow you. Okay, so is my eyes not working good? It's perfectly okay. So this is 100 millivolts, right? For ground connection is 100 millivolts. For sensor circuit ground, it's 100 millivolts, just the same. For switches, switch connector is 300 millivolts, and for starter sonar it's 500 millivolts. And of course, like we said, you would also have to check to see the specific recommendation for the specific application. All right, so troubleshooting procedure, examine diagnostic strategy for open circuit problem, high resistance problem, unwanted parasitic load, shorted to ground problem, and feedback problem. Okay, so here is a flow chart of and it's a 6-step troubleshooting plan. Okay, so what this essentially tells you is that first you must verify the customer's complaint, right? So you will have to do a test to ensure that what the customer is explaining to you is what is actually happening. Because sometimes, all right, so first we verify customer complaint, and then we determine the related symptom. We then analyze the symptoms, and then we isolate the trouble, correct the trouble, and then we check for proof of operation. Okay, so the objective is to determine what needs to be done to verify problem, check component for related symptoms, use circuit trace technique to analyze symptoms, symptoms to determine problems for diagnosis. Use EWD to isolate problem. Use repair techniques for wire, terminal, and connectors. Step 1. Verify customer complaint. Identify what the customer is describing. 2. Is it a problem? Is it intermittent or continuous? All right. Sample for customer complaint. Stoplight does not work. Step on the brake pedal. Look at the brake light. The problem happens every time the brake pedal is depressed. Step 2, determine the related symptom. Most electrical circuits consist of two or more loads that are connected in parallel. Entire different circuits are related to another circuit by parallel connection to common power source, fuse, or ground point. Clear sensor or switches function in which a single switch operates a number of different circuits, such as left and front door, courtesy light operated both the interior lighting and the key warning buzzer circuit. Next one. This one. All right, so isolate the problem. When analyzing the symptom in step 4, you trace the path of current flow in the part of the circuit that were good. You will now see section of the circuit that have no trace on it. Places where there is no confirmed current flow, always sorry, current flow. Anywhere you have no trace current flow in the potential problem area. If you are working with a photographic of the diagram, sorry, if you're working with a photocopy of the diagram, circle all the location where the problem could possibly be. This gives you a good visual reference of the place you will potentially need to check. So basically what you're going to do, you're going to look at the diagram and you're going to trace the diagram for the problem area. And you're going to pinpoint those areas. You're going to look for connection numbers. You're going to look for color wires. And you're going to trace all the way through the end and look if you find any deviation in the voltage or the source at that point. To isolate the problem, there are 3 actions you need to make. 1, on the wiring diagram, find the area that are possible problem areas. 2, determine where to begin making the checks. And 3, make your inspection. Okay, so troubleshooting procedure. Step 5, correcting the problem. This may be repair or replacement of components, wiring, service to service connection, or connectors, terminal, and ground point. Troubleshooting procedure. Certain circuits require special handling. The airbag system, for example, requires you to disconnect the battery and wait up to 90 seconds before servicing the system. Always refer to the service manual for specific service or special service precautions. If the battery needs to be disconnected, write down the customer's radio station, preset program and station, and reset the clock after connecting the battery. And what I would strongly recommend is that before disconnecting the battery, is that you check to see if the radio has any security or coding feature that you will need to have before you disconnect the battery. Or you might need to add a power source to maintain that before disconnecting the battery. After making the repair, you must verify that the problem was actually fixed. Operate the circuit as thoroughly as you did when you first looked at the car, making sure that all the functions and features of the circuit are working properly. Sometimes a circuit made simple problem. Sometimes a circuit has multiple problems which are causing it to be incorporated. This this recheck of the circuits ensure that the customer will be satisfied. A satisfied customer means that he or she will return to the dealership for service and tell their friends about the experience too. Hold on, go back. All right, so precaution, ignition switch, expression, int. The type of ignition switch used on this model differs according to the specification and the vehicle. The expression listed in the table below are used in this section. So we have expression, ignition switch, position, engine switch, and condition. So the expression is ignition switch off, the position, the steering is in the lock position, and the engine position, engine switch condition is off. Ignition switch on, steering lock on, beg your pardon. Expression, ignition switch is on, expression is on, engine is ignition on. This can go somewhere. Okay. For the expression, ignition switch accessory, accessory on for engine. For startup, engine start, engine condition, engine start. And there are some parts location. So for one, we identify our spiral cable subassembly. Two, oh, because it must be a stem. So two is your steering pad switch assembly, and three is your on button. Three is your on button assembly, and four would be your main body ECU, which is your multiplex networking, and five would be your instrument panel junction block assembly. So over on the other side now we have low pitch on assembly, and 2 is your on relay, 3 is your engine room relay box, and 4 is your on fuse. Of course, incorporated inside the fuse box. Okay, so symptom and suspected error. If the on does not work, on doesn't work, it could be fuse relay, low pitch on assembly, spiral cable, steering pad assembly, on button assembly, instrument panel junction, block assembly, or wire harness. If on sounds all the time, it could be a relay, spiral cable, steering pad, on button assembly, instrument panel junction, block assembly, steering pad assembly, on button assembly, instrument panel junction assembly, wire harness. On sound all the time, on relay, spiral cable, sub assembly, steering pad, switch assembly, on button assembly, instrument panel, junction block assembly, main body ECU, multiplexing network body ECU assembly. The data list and active test, performance active test in using the text stream to perform active tests allows relay VXV, which is vacuum switching valve, actuator and others and other items to be operated without moving any parts. This non-intrusive functional inspection can be very useful because intermittent operation may be discovered before parts or wires is disturbed. Performing active tests, performing active tests early in troubleshooting is one of the ways to save diagnostic time. Data list information can be displayed while performing active tests. So you could set up a test plan, and then you could, while doing the test, you could also be monitoring your data stream to see the level of operation, what is operating, what is not operating, based on your test plan. So A, connect the text stream to the DLC. 3, turn the ignition on, turn on the text stream, which is a Toyota genuine scan tool, that is text stream. Enter the following menu: body electric, main body, active test. Perform active test according to the display on the text stream. Body electrical, main body active test. Test the display measurements, item control range, diagnostic notes. Vehicle on and off. So that's how you would actually do the test. So what you would press in the end is on and off. So the on. If you press it and it come on and the on don't work, you know something. And if you press it and it come on, you know something. And these are just connectors, different connectors within the junction block. All right, and this is a follow-up of the junction block internal circuit. So these are the information you will actually use to pinpoint where the possible source, where relays and control and other controlling devices are located. Yeah. All right, so we're gonna finish here. We're gonna pick up on the next class. We just run through these lighting symbols. This is not part of the for the course, but for your benefit, we'll run through it. So we pick up on these at the next class. All right. Like I said, it's always a pleasure um being with you. It's a basic you want to add anything else. Yeah. So, you want to see.
Evening, everybody. Yeah, these last set of slides was not necessarily designated for this class, but nonetheless, it's in case we have some real beginners in the class. Just make sure to put them up there. So if you see something there that you're not clear about, you could make mention of it. However, City and Guilds does not require you at level 1 and 2 to do a practical for this exam. However, we do because we want to make certain that we cover the fundamentals of circuitry um, and lighting system. But if you notice that a lot of the circuits that we've been using are basic circuits, and it's not necessarily the circuit, but it's your ability to test the circuit that is being tested, that is being assessed. So we are going to be designing for practicals not this Sunday coming, but the following Sunday. Following Sunday, Mr. Scott? The following Sunday at 32 Oak Road. We're going through some lighting systems. So we have we went through the schematics here. We're going to print the schematics or send it to your email so you can follow through and understand the format. And then now you are going to be the person who is going to set up these circuits and test them. So it's not just a matter of connecting wires. We're going to be setting up bugs in it, right? Even after you have finished set up the circuit, we want to set problems in it. We want you to use your meter and your tester to solve these problems, right? So it's all about doing a voltage drop, um, um, finding your source or whether the ground or its power source, whatever it is. And Mr. Scott is gonna put together for you to test and check. That is what you're going to be doing. And then now we're gonna put you on a vehicle and set up the problem on the vehicle for you to test and check, right? To put your knowledge to use. So we desire that you have good foundation in electrical and basic circuits, so that when you move forward, you're not going to be at a loss, because this is the foundation level, and you cannot move from this level and don't understand to wire these circuits easily and test them properly. All right. I did ask that everybody try and get a digital multimeter and a basic um, test light for now, because we're dealing with lighting circuits, so it's not so detrimental at this point. When I get down into level 3 and 4, then we're going to be requiring you to use um, the LED test so that we don't damage any circuits. All right, but for now it's just basic circuitry. All right, so next class is not a regular class. Next class is going to be your test. I'm going to give you a final test um, for that session, and then we're going to prepare for the practical, which is the second Sunday from now. Your exam is on Monday, God's willing. I had noticed City and is had a little issue with their global system that they use to do worldwide testing. I had it from yesterday, so I'm hoping that on Monday we don't have any issues. By weekend or maybe by tomorrow, I think what you need to do is post in the group between 9 and 12 what time schedule would work for you in terms of doing the exam, so that we can know how many persons coming in the from the 9 o'clock to probably 10 o'clock, and from 10 to 12, that kind of stuff. Please post it in the group so I can know, and I'm schedule it accordingly, so we don't have too many people in the exam room, because an exam, we don't want anybody bungling up. And you cannot use your cell phones in the exam. You understand the rules of exam, so we expect that you will adhere to those same rules. All right. The exam is very manageable. That's a better word. Um, if you do your revision, you shouldn't have any problems with the exam. And most of the questions is coming from the hybrid side of the course, and a very one, and maybe one or two from the electrical. Is electrical, as I say, is a bonus to the hybrid class, really. Most of the question is coming from the first part of the session. Practical, you don't have to worry about being pressured about it as related to city angles, but we really want you to learn how to understand and test circuits, and that is why we're doing it. All right, so please make an effort to absorb this information. You have questions, put it in the group. If you think we can add something to make it more interesting, add it to the group, right? And we will make it as informative as much as possible. So this is wrap up time now. So let me just inform you, for all those persons who have administrative um, things to complete as relates to registration and the cost for the course and stuff, you need to settle this before exam day, Monday morning. All right. All outstanding must be cleared up before exam, please. Um, Nonetheless, we appreciate the sacrifice, and I know it's rough out there and things are hard, right? But remember, we have our obligation on our sides to our teachers and facilities and that kind of stuff. All right. There is one more requirement. We have to pay them a lab fee of $2,000 to use the lab. So you can just walk with that for Monday morning. All right. Um, I think that should be it. Thanks again for sharing. Please study your electrical that you did today, and prepare yourself for a little test. It's not something we're gonna use against you, really. Right? It's a notebook test. It's participating. So you can share your thoughts on it while you're doing it. So it's interactive. Right? It's more like an AC format. So you can participate like that. All right. What is important is that you pass this exam from City and Guilds. That is very important. All right. So focus on that, and I give you a week break to focus on the practicals and get the things that you need for practicals. All right. Again, thank you very much for your sacrifice and your time from family and friends. And for those who are traveling, God go with you and hope you reach safely. And we will meet again on Thursday, same time, God's willing. So have a good night, everybody. All the best.
And
Okay, bye bye.